Energized greetings from Trafolo. I am Juris Vencels, co-founder. Trafolo is building simulation software. It is a software that allows engineers to virtually prototype their designs. Like, engineer is a brain who creates this big idea, and the software is one that tests it. Click, click. This picture is a transformer which is moved in Australia just after the Second World War. This is a time when globally in the world we have a very steep industrialization and electrification. New power plants are produced, new electricity consumption devices are developed and discovered. So the world is very thirsty for electricity. Transformers allow that electricity to be delivered from the place where it's created to the place where it's used. And it's surprising that it is more than a century-old technology, but it is surprising that it's still being developed. And I would say that in a 30, 40 years, we typically get not an evolution, but revolution in technology. Why it matters? So you all know that we try now to push solar, wind, renewable electric sources, and it's all good. And electric cars are also very good. But what we typically do not see is what runs on the background. Electricity, when it is produced, it's oftentimes very dirty. Not dirty in terms of CO2 or emissions, no. I mean, we cannot take that electricity and directly plug in it to our car. We have to somehow smoothen it out, make it usable. So apply the right voltage, the right current. And it's a very challenging task. And for doing that, we need magnetic components. On the other hand, this global warming, etc., may cause us very severe heat waves, also very unsteady weather conditions, and blackouts might happen. They have happened before, often, and they still may happen in the future. And to tackle this issue, we would like to have some backup electricity sources. For example, add batteries to our energy system so that it kicks in when we need, when we are disconnected from the grid. And again, so in order for that technology, in order those batteries to deliver this power, we have to somehow convert it. And magnetic components and transformers are helping with us. Whereas also the problem is that our electric grid, which was developed like a century ago, it was designed in such a way that large electrical producers feed electricity to the grid. And there are many smaller and larger consumers of electricity. And if you put your solar system in Marupe to the grid, and if your neighbors also put to the grid, and if you, in a sunny day, start putting that electricity to the grid, if there is electricity is too much, then you may just get an overvoltage and basically cause the trouble to the grid. So it's a bit more tricky than just adding more solar, wind, etc., etc. This is the history of transformers. It started with very, I would say, simple designs made around electrical steel. And we still see those designs like in transformer boxes close to our homes and in energy-producing stations, like in kegums, for example, you can see there's a lot of electricity wires, and there will be large transformers somewhere. Then, 50 years it took for us to discover new materials that can basically improve the properties of electrical steel. And ferrite transformers arrived. it allowed us to use higher frequencies. And a good example where those ferrite transformers are visible for us. And so if you remember, like older phones, they had a very large chargers, like those older Nokias. It was very bulky and heavy. Nowadays, you may have much smaller and lighter charger, but with a many times larger power ratio. And this is thanks to mostly to those transformers that are inside this power supply. Then we moved to 1990s. A new technology with so-called planar transformers are developed. And this is thanks to the knowledge that we have built during all those decades. Engineers got smarter how to produce effectively that new type of transformers. And also simulation software kicks in. And this is is a critical part. So simulation software allows us to test and validate our ideas. And finally, it is just a new recent development. Those are called integrated magnetic components. Imagine that a transformer is not built by hand by some in manufacturing by someone who puts together it, but it can be like a 3D printed or etched on the plate, and you can build those circuits together with those magnetics in automatically. And this is a big thing, because if we imagine how many electrical devices we have around, and in the future we have even more, so even saving 10 or 20 cents on this magnetic component is overall a very big, I would say, advantage to us, consumers. And Trafolo. So Trafolo is simulation software. Engineer uses the software to prototype, test his ideas. And why it matters is because prototyping is very expensive. To make a prototype, typically industry spends hundreds or thousands of euros per each, and it's very wasteful. Also, our engineers nowadays are very busy. So instead of doing engineering, they oftentimes have to do some business-related activities, like preparing offers to their clients and some other BS, as they call. So simulation software is, which is specialized in our case, it allows them to very quickly do their job, test their ideas, and to move forward with their business activities that they don't like. And last but not least, why cannot we use AI for everything? Well, I think that we can teach AI to think as an engineer, actually. AI, artificial intelligence, it is a good tool that can find patterns, that can grasp the idea, but you have to feed a lot of data into it to train it. And computer simulations are a great tools to feed the data, to produce the data, to train AI. So in the future, a lot of stuff that we will use will be basically designed by AI/simulation software. So we are not working with AI now, but we are building a tool which could be used for AI. This is the team for the competition last time, a year ago, was very successful for us. We still have two physical co-founders, and the third one is virtual guy who helps us, is freelancing and helps us with all that stuff that we are not good at, because we both are from the technical world, I would say. And speaking about how Norway Grants helped us, so there was and there is still Innovation Academy, and we participated. We started as private persons, let's call them, and then assembled a team. I found Mark, my co-founder, and although we have graduated from Innovation Academy, we are still alive, and now we have found a distributor in India, and hopefully if we survive, then things will go well and we will be the #1. Thank you.
Best of luck. Very inspirational. Maybe some questions from the audience, please. Oh, thank you. 1 second.
Yeah, I wanted to ask about where your product stands against the competition. And for example, I'm not sure if SolidWorks supports electromagnetics, and if it doesn't, then I guess, do you imagine the software to be something like that?
I didn't get the last part of the question, but you mentioned it SolidWorks.
Yeah, I guess how does the software works in the,
Yeah.
What's the idea for the software?
Yeah, so Trafolo is not the only one, the only softwares that can be used for designing magnetic components. Our key feature is that we are specialized. We build an application that focuses on magnetics. So those general purpose simulation tools, they typically have thousands of all kind of features and tools. It's like using Photoshop just to overlay 2 pictures together. Like you can do it in Paint in principle, and it's much easier to do. But engineers, for sometimes very basic tasks, have to use very complex software. So yeah, we are going into being able to do what those large packages can do, but do it more efficiently and easier, because time is, you know.